Section 10.4 is on other angle relationships in circles. So it says if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of its intercepted arc. Okay, so basically if I have, I don't know, 240 degrees over here, and I have 120 degrees over here, this angle, angle 2, do you guys see that it intercepts the arc that has 240 degrees? So how much do you think angle 2 is going to be then? 120. And then what about angle 1? So it intercepts the arc that makes 120, so how much is it going to be then? 60. Yeah, so that's the relationship between them. It's half, which we kind of talked about last time a little bit. So it says line M is tangent to the circle. Find the measure of RST. So if I have 115 degrees, what do you think this arc RST is going to be? 230? Yep, 230, exactly. So if I have 104 for the next one, well, the angle here is going to be half of that, so we're going to have 52 degrees. And it says find the angle of the measure of CBD. Well, that's what we just found, right? So that's equal to 52. But what if I wanted to find other things in this picture? Could I find some other things? What about this other angle on the other side of it? So if I have 52 degrees, what about this angle right here? Nope, bigger. I see what you're doing. You're making 90, but we need 180, right? So what do you think? So 180 minus 52, 100, and 128. Did you say just 28 or did you say 1? Oh, you did? Oh, I thought you just said 28. I was like, all right, and then double it. So we're going to get 300 and, not 300, jeez, 256. Does that make sense? So do 256 and 104 add up to be 360? They do. So we could have done this in a different order as well. We could have done the 104, we could have found the 256, and then we could have had it to the 108. So these are all interconnected. So you could definitely create some of those problems where you have like lots of things you're finding in the angles. All right, so when two lines intersect in a circle, there are 3 places where the lines can intersect. Okay, so let's think about it. So if I have my lines intersecting, they could intersect inside the circle, right? Something like that, right? They could intersect outside of a circle, or they could intersect where? On the circle, right? Okay, so when they're intersecting on the circle, that's what we were just talking about. So we were saying, well, if I have this angle here that's 40, then this one's going to be double. It's going to be 8. Okay, so that's what we talked about last time. But we haven't talked about what happens when we have lines that intersect inside the circle or outside of the circle. So there's going to be 2 different rules for that. So it says if 2 chords intersect in the interior of the circle, then the measure of each angle is half of the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so it's going to be half the sum. Okay, so I meant to sharpen some colored pencils for you because it really helps if you have colors. So Joe is prepared. He has lots of colors there. Okay, so let's look at it. So if I talk about angle 1 right here, do you guys remember intercepted arcs, how I talked about the Pac-Man eating it? Right? Do you guys remember? Like Pac-Man's eating the intercepted arc. All right, so what are the 2 intercepted arcs here? There's 2 of them for angle 1 because angle 1 is formed by these 2 lines. So if I extended them, do you guys see what arcs are trapped inside of that? DC and AB. Do you guys get it? Do you see how it's kind of like intercepting those 2 arcs? Okay, so angle 1 is going to be half of the sum of the measure of arc CD added to the measure of arc AB. But what about angle 2? Angle 2 is a little bit different. What are its 2 intercepted arcs? Do you guys see it would be this one and this one if I was talking about angle 2? So measure of angle 2 would be half of the sum of AD added to BC. Okay, so it's a little bit different. Does it make sense? So you have to know where those lines are extending and what arcs it's intercepting. So again, so if I have a picture and I had something here, if I have an angle right here, angle 1, its 2 intercepted arcs are right here and here. Do you guys see it? It makes like a little bow tie. Got it? All right, it is not It is not this one and this one. Do you guys see the difference? Okay, so be careful with those. All right, so it says exercise. Each group will choose a type of intersection. So the first one is a tangent secant. So you guys all have rulers. Probably need rulers here. You guys kind of pass these out. Sorry. I really thought I could reach, but I can't. All right, so a tangent secant intersection is going to be where a tangent line just touches on the edge and a secant line slices through. Maybe I should use a ruler too. So tangent's just going to touch on the very edge, and a secant's going to slice through. All right. So draw a tangent secant. It can be any of them. And obviously they could cross over here, right? But we're really not going to worry about that part of the picture. We're just going to kind of worry about just that part. And then a tangent, that made what we called the ice cream cone theorem. Do you guys remember that one? So if I have a tangent, it's going to look something like this. It's just going to touch on the outside there. And then the last one you have on your page is a secant-secant. So secants can slice through, right? So let's say I have one that slices through and then another one that slices through. All right, and you can kind of get rid of the excess like I talked about. We want it to kind of match at a point there. Okay, so yours can look different than mine. Okay, so I used to have students do a little exercise where we found all these different arc measurements. Okay, so we can find arc measurements by drawing in the central angles. But the tricky part about this is I didn't draw the center to your triangle. Or not triangle, to your circle. So it's a little tricky to do. So if you don't have the center right, it messes up these measurements. So here's what we're going to do. So let's say that this was, I don't know, let's say it was 100 degrees. So kind of estimate on yours. There's another arc that's intercepted by this picture. Do you guys see? So Pac-Man is eating, not just that 100 degrees. What else is he eating? Do you guys see another piece? Isn't it right here? There's two intercepted arcs that are created. So let's say this one was 40. This angle that's out here is going to end up being half of the, well, the last one, what we just did was half of the sum. Okay, the ones that are on the outside is going to be half of the difference. So it's going to be 1/2 of 100 minus 40. So you're going to do that outer minus the inner. So the outside arc, inside arc. So what's it going to end up being? Yeah, it's going to be 30, exactly. All right, well, the same thing happens for these ones. But if you have a tangent, and let's say I knew from here all the way around, it's clearly more than 180, right? Let's say it's 220. What if I knew that was 220? Well, what about the inner arc then? What does this inner arc have to be? Yeah, it has to be 140. Okay, trick question. What if this was X out here? What does the inner one have to be? Yeah, what if it was just X and not 220? It has to be the rest of the circle, right? How do I represent the rest of the circle? 360 minus X, yeah, so these can get tricky. All right, so what if I had 220 and I had 140? Well, this outside angle ends up still being half of the difference of those intercepted arcs. So it's going to end up being half of the 220 minus 140. Yeah, so what is that? 40? Is that what you said? 40? Yeah. All right, yeah. All right, so what do you think this one is? Well, it's also half of the intercepted arcs. So half the difference of the intercepted arcs. So find the intercepted arcs. So we have outer and we have inner. The outer, let's say, was 50 and the inner was 20. this is going to be half of the difference of the intercepted arcs. It's going to be 50 minus 20, which is 30. Whoops. So half of that is going to be 15 degrees. Okay, so it's always following this pattern. So you have the outside minus, so the outer arc minus the inner arc divided by 2. All right, so it says if a tangent and a secant, two tangents or two secants intersect on the exterior of a circle, so if we're intersecting on the outside of the circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So all we have to know is, do they intersect on the outside? Do they intersect on the inside? Do they intersect on the circle? So how about this first one? Outside, inside, on the circle. Where's their intersection point? This is an inside one. Do you guys see it? Because they're crossing on the inside of the circle. So our measurement x, this angle measurement, is half of the, do I do sum or difference of the intercepted arcs? I do the sum, right? So I'm going to say that x is equal to half of the sum of the intersected arcs. So I'm going to add that 60 plus 20. So I get half of 60 plus 20 was 80. So I get x is equal to 40 then. Okay, but this next one is outside, right? So my angle is half of the difference of these intercepted arcs. So I'm going to say x equals 1/2 of 136 minus 38. So half of, well, that's going to be 98, right? 2 less than 100. So x is going to be what? 49. Yep, perfect. Does that make sense? Now, obviously, they could get more complicated. You don't always just have just plain x. And sometimes the x isn't the angle. Sometimes it's one of the arcs, right? So they can be a little bit more complicated. So let's try these ones. Okay, so you have to identify what the angle is and what the arcs are. Okay, so again, like I was saying, colored pencils kind of help. So you can say, oh, these are the intercepted arcs. Got it. Identify the angle. The angle's on the inside. Right, that's not an arc, that's an angle, right? So that 45 degrees is going to equal half of the difference or sum. Inside or outside? Sum, right? So I'm going to add my 2x to my x. So I have 45 equals 1/2 of 3x. So these can get annoying because some people like to find this fraction. Sam, you with me? So they like to multiply this 1/2 in and say it's like 3/2. Okay, we don't want to use fractions if we don't have to, right? A lot of you guys still don't like fractions, so that's okay. How can I get rid of the 1/2? Multiply by 2 on the other side, right? Because saying 45 is half of 3x is the same as saying, well, I could multiply by 2 and say 90 equals 3x, right? Because half of 90 is what gives us 45. So I'm going to say 90 has to be equal to 3x. So x is then 30. So you could multiply by 2 and multiply by 2 to get rid of that 1/2. All right, so you guys want to try the next one? So try 4 and 5. See if you get 4 and 5. All right, so this next one should be x, right? That's our angle. And our two intercepted arcs are the 170 and the 30. So x is equal to half, sum or difference? Difference, right? So outer minus that inner. So 170 minus 30 is going to be 140. So you should get half of 140. So did you guys all get 70? Yeah, so you feel pretty good about these? All right, here are the tricky ones. I always hated these ones in school because it was like I had to see all the numbers. And if I didn't see the numbers, I was like, wait, it's missing something. Well, it's okay. It can be missing something. You still get that number, right? So its intercepted arcs are the 110, but also the rest of that circle is an intercepted arc too, right? So if you have 110, what's the rest? What's the part in blue? 250, right? So x is going to be half of the 250 minus the 110. So it's going to be half of 140, which is 70. Okay, so here's the tricky one. So if I have x, what's the rest of the circle then? Ah, close. Not 2x, though, because it has to add up to be what number? 360, right? So you're thinking like what we were doing before, where you're like doubling to get the other one. So if I want the rest of the 360, how do I represent that in math? Yeah, 360 minus x. So that's a little tricky. So this is going to be 360 minus x on the outside. Okay, so be really careful when you write this one. So I have 45, so that angle is equal to half of the difference of the two arcs. So what's my outer arc? 360 minus x, right? What's the inner arc? X. So don't forget that second x. So that's outer minus inner. Some people just write 360 minus x and they're done. All right, it's actually 360 minus x minus the x. Do you guys all see why that's true? Okay, so as we do this, I would probably multiply by 2 to get 90, just so we can get rid of that 1/2. And then I have 360 minus 2x. I can subtract the 360 over. So I get what? 270 equals negative 270 equals negative 2x. So what's x then? 135. Good. See, you're good at your mental math. Sycamore trained. You have to do everything mental math at Sycamore, don't you? All right. Does that make sense? Do you guys understand 10.4? All right. Stop there.